All right. The timer's telling me that it's been 2 minutes. So buckle up. I hope you guys have everything you need. You're in for a treat this evening. We'll introduce our speaker for tonight's Science Talks shortly. First, I want to introduce you to my co-host this evening, Tiffany.
Hello, everybody. Welcome to Science Talks.
Awesome. So for those of you who are new here, I noticed some familiar faces, but for those of you who are new, Science Talks is about exploring the latest ideas in research and science. This is the second talk that you're a part of this evening. So thank you for joining us and spending your evening with us. Just a couple housekeeping things before we get started. For Zoom etiquette, we just ask everybody to mute your microphone. During the Q&A, you can use the raise your hand feature or just chat in the box, and we'll go through and try to get as many of your questions as possible for our speaker. Just so you're aware, the event is being recorded and streamed live this evening. So if you do not want your face shown, hide your face, but we always love to see your smiling faces. So before we jump in, we just ask for those, for the conversation that we're going to be having. We've brought in an expert, and this is not a debate to have with them, but a chance to engage and ask questions. And so we'll welcome a wide range of questions. We also offer a safe environment to bring any sort of curiosity you have, but also to keep an open mind and to be kind. And so please don't promote anything or come with an agenda. Come for some honest conversation. All right, so just so you know what to expect, we're going to have a talk from an expert. Then we're going to go through a Q&A portion where you have a chance to engage the speaker in some questions. And then we'll do a wrap up, and we'll get a group photo with everybody who, for those of you who want your face included. Might get shared on some social channels, so you might get famous. So that's what to expect from this evening. And so I will just pass this over to Tiffany, who's just going to give a few notes before introducing the speaker.
Hi, everyone. I just wanted to do a quick thank you to all of our amazing partners and sponsors for this event. We could not do this without them and their support. Each and every one of them is absolutely amazing and such a pleasure to work with. Can we switch to the next one? Some sponsors that I would like to give a shout out to are the City of Abbotsford, the Vancouver Foundation, the Abbotsford Community Foundation, University of the Fraser Valley, the Abbotsford Tech District, Envision Financial, Connext, UFB Alumni, TEDx Abbotsford, and the City of Abbotsford. Thank you so much for all of your amazing support. And we actually have a surprise for you guys. We have Gavin here from the Abbotsford Tech District. Gavin, welcome.
Hi, Tiffany.
Hey, great to have you here. I just wanted to ask you a few quick questions because we're all, I'm sure, very interested on what the Abbotsford Tech District is, and we would love to know some more. What is it that you guys are trying to accomplish here?
You bet. I'll say as little as possible because this is the Lenore show, not the Gavin show. But we're a planned live, learn, work community on Sumas Mountain, the cornerstone of which will be an accelerator facility for academic and commercial work around agricultural innovation and food security.
Very great. That's amazing. That would definitely be a huge benefit to Abbotsford. And what was it that made you sponsor Science Talks?
Yeah, we love what you guys do with Science Talks. I think it's great that you're bringing people together to talk about ideas and science and innovation. And that's very much in line with our thinking. And for tonight's session in particular, we're big fans of Lenore and the work that she's done, leadership she's taken on the Premier's Food Security Task Force. So we're particularly excited to be supporting this evening presentation.
Oh, well, thanks again, Gavin, for joining us. It's great to have you here. And upcoming is Dr. Lenore Newman. We are very excited to hear her talk today. She will be giving us a presentation here on new technologies and how they are changing the face of agriculture. The advancements in technology, computing, and genetics can help us produce more food while being more sustainable. It could also be a little disruptive to the agricultural industry. She is exploring some interesting topics such as milk protein science and the fascinating world of fermentation-derived dairy products. Lenore Newman, she is a director at the Food and Agriculture Institute of UFB, where she holds a Canada Research Chair in Food Security. Lenore is also a member of the Royal Society of Canada's New College. She researches agricultural land policies, technologies, and bioengineering in the food system. She has also published 2 books and holds a PhD in environmental studies from York University. When she isn't here working with us or in her lab or researching some fascinating topics, you can often find her experimenting with some new recipes or spending time in the outdoors. Welcome, Lenore. It's great to have you.
Thank you very much for having me. And it's wonderful to talk to all of you tonight, even though I'm in my living room. And I will say that tonight my living room is, as always, on Musqueam unceded territory. And it gets a little more complicated with all this zooming around, but that's where I'm at tonight. And I'm really glad you're joining me tonight, and it's great to be doing this. And I'm lucky, as I have a really great job that, to be honest, has been made even more complicated and interesting by the pandemic. I get to spend my time talking and working with people who are building tomorrow's food system. And it looks really interesting. And tonight I'm going to talk a little bit about some technology that may happen 5 years from now, or maybe never. And part of my job is to look into the future and say, well, if something happens, what does that do to the agricultural community, to the land base, to the industry? And that's a bit what I'm going to talk about tonight. As mentioned, I'm the director of the Food and Agriculture Institute at UFB, and we really have 2 main areas of focus. We look at land use, and I'm certainly known for my opinions and work on the land reserve, and also agricultural technologies, in particularly intensive technologies, intensive horticulture, advanced protein products. But all of these technologies, these little bit of knowledge, they fit in a larger puzzle. Every day, everywhere, humanity has to feed itself. And that's a massive undertaking. As I'm primarily a geographer, I want to start by talking a little bit about land. Surprise, Lenore's talking about land. In 1998, the Perry Commission made a very astute remark that the problem of balancing competing uses for land is at the root of all political discussion in this province and will remain so forever. That's kind of true, especially when it comes to food production. But there's a bigger global picture I like to remind people about. Globally, there are currently about 1.9 billion hectares of cropland on Earth. And if you're like, wow, that's a lot of turnips. Yeah, it is. That's about 14% of all the land on Earth that isn't under ice. But another 25% is grazing land, which means that agriculture is by far the dominant human impact on the planet by area. And we know we could expand that a little bit if we had to. But we're also losing land due to sea level rise, due to erosion, and of course the one I study in depth, urban sprawl. Cities cover about 4% of the Earth's land area, and every year we lose about 2 million hectares of farmland to sprawl, which is about 1/1000th of a total So it would take about a millennia to cover the whole planet in cities, but we're really doing a good job speeding that up. So we need to pay close attention to that number. And there are other losses to consider. We estimate that we need the production equivalent of 10 million hectares a year in new farmland just to keep up with population growth and with erosion, salinization, all of these things, including climate disruption. And this is a challenge. And we know that around the world, people are snapping up farmland. Countries are seeing their farmland bought up. Farmland price increases run about 20% a year in many areas. So land is in some ways the new gold, except now with the pandemic, gold is the new gold. But that's how these things tend to go. The UN keeps an eye on all these numbers. They have teams who do it. They feel we could expand our farming about another 20% if we had to, but we would be doing trade-offs. We would lose the Amazon, we would lose maybe the Boreal, we would lose things maybe we don't want to lose. And so one of the reasons I pursue agricultural technologies, and I get asked that question a lot, it's like, Lenore, why are you pursuing these sort of technological rabbit holes? Is that over the centuries, the only reason we've kept fed on the same, the amount of land we have with exponentially growing population is we get more food per area. And that's particularly crucial in an area like BC. And it's very important right now. COVID has demonstrated to us we benefit if we can produce food near market. None of you are probably worrying about the things that we produce all of locally, like chickens, eggs, milk, and right now blueberries as well. We have a lot right now. So supply chains being shorter is a benefit. Also, the food tastes better. And we know from a variety of studies, people who live in areas with a lot of production that's available to them actually have better health outcomes. So next time you roll past Lep's Farmers Market, you're probably increasing your health. So give them a big thumbs up for me. Maintaining farmland in BC, as you know, is contentious and not easy. Most of the province is really only suited to mountain goats. Only a small area of the province can be used for land-based agriculture at all. 2/3 of the total area is mountain slopes, rocky land, watery areas. And what we know is about half the land has no capacity to produce food whatsoever. And about 40% is only suitable for natural grazing or permanent pasture. And of that remaining land, very little of it is completely without any limitations. And a lot of that is sitting in Abbotsford, so we're very lucky. And we really need to make sure we protect that land, but also use technology to increase the marginal lands as well. So what's happening around the world? And I'm very frustrated because I can't actually travel right now. Those of you who know me know that I'm usually wandering around looking at things, but we're all talking on Zoom and still talking about new technologies. And a weird side effect of the pandemic is that there's been an explosion in agricultural technology around the world. In Iceland, greenhouse companies are tapping geothermal energy to grow everything from lettuce to avocados. In the United Arab Emirates, microclay is being used to allow cultivation of the desert to produce hot weather crops like watermelons. Companies are working to grow rice offshore in floating paddies. That one is fascinating, by the way. I think it's really interesting. And in Singapore, companies are working to grow shrimp meat in bioreactors in order to spare the last mangrove forests. And here in BC, local companies like Terramera are using bioengineering to produce crops that create their own nitrogen fertilizer. These are just some of the things that we're seeing, and some of them will fail, but some of them will reshape agriculture. Part of my job is to understand how they fit into existing policy. How do they fit into the land base? And I really believe technology is like any tool. It's neutral. The outcome depends on how we use it. You can take a wrench and you can tighten a bolt, or you can use it to bonk someone on the head and steal their pizza. That's on you, not the wrench. However, as someone interested in policy, I need to ask the question, if the technology is adopted, what do we need to make sure people are safe? How do we ensure British Columbia is on the forefront of this agricultural revolution rather than playing catch up? How do we help our industries adapt and get ahead? And I decided, because we're all kind of struggling these days with the pandemic, I wanted to use my most blue sky technology that I follow that you may not have encountered, which is, as mentioned, milk without the cow. And so let's go and explore the wonderful San Francisco world of cellular dairy. Dairy is already changing. Animal-based dairy is competing with plant-based dairy very, very vigorously. And fermentation-based or cellular-based dairy is now the new player. Last summer, I was in Stockholm on a research trip. That seems a million years ago now. And I fell a little in love with a product called Oatly. I'm a bit lactose intolerant, and I try to avoid liquid milk, but here was this country of lovely people making magic milk out of Canadian oats and Canadian canola. And it was smooth, it frosts in lattes, and I even had a milkshake for the first time in years. And I came home thinking, well, that was great, they're sure ahead, only to find that plant-based madness was everywhere. I was on the Premier's task force on food security at the time, and one of the questions we were given was to advise on how British Columbia could engage with the plant-based shift. And everywhere we went, we encountered excitement. In the Netherlands, the government was hoping to lower meat and dairy production because it uses most of their land, so they could shift into more high-value horticultural crops. And one of the ways they wanted to do so was to produce more milk substitutes. And in Saskatoon, where one doesn't expect usually to find, a lot of raging vegans, but in Saskatoon, we found they were absolutely crazy over oat milk and are opening a new major processing plant to deal with demand. And they're also home to the protein supercluster, a major research group addressing plant-based protein. And it's one of the things I like to remind people, Canada's a winner in this industry because we produce the inputs, whether that be oats or canola or pea protein. We have so much potential in this area. And there's a strong shift that seems to be continuing. People are rethinking a sacred cow that is, well, an actual cow. And let me be very clear, I'm fond of cows. I'm a descendant of Sami Finns, and we like to herd animals. We like large animals that run around and eat greens. My family actually ran one of the earliest dairy farms on the Saanich Peninsula, and my great uncle taught me to milk when I was 6. And for the record, I was really bad at it. And he was very stern. There was crying involved, and I think that was the end of that. But cows, lovely as they are giving us challenges. Remember, I said currently 40% of the Earth's non-glaciated land is used for agriculture, either grazing or crops. Now that it's clearly a problem, that's a lot of land. But what's interesting, about half those calories go to people, 36% go to animals. The rest go to ethanol, and that's a totally other problem for another day. So anytime there are about 1 to 1.5 billion cows on Earth, and recently in China, a dairy passed a really stunning landmark. They milk 100,000 cows. And the scale of this is why livestock accounts for about 14% of greenhouse gas emissions. And so we know we're hitting the limit of what we can do with animal technology. And there's a group at Guelph that have shown we can't possibly scale animal agriculture to feed the maximum population in the style we're accustomed to. So what do? Well, plant-based alternatives are fine, but we have deep cultural connections to actual dairy, to cheeses, to ice cream, to poutine curds. And so we kind of need something a little better. As much as I like Oatly, we need slightly better substitutes so we can produce the foods that we love in another way and produce another option. And I want to make it clear, this isn't going to eliminate dairy. It's going to eliminate a subset of dairy that we probably need to get rid of, and places like Avalon and Birchwood will still be doing their amazing stuff. But what we're really looking at is, how do we address that sort of middle market where you go into Safeway and you pick up a block of cheddar because you're making, you're making pizza or something. What can we do? And there's a really neat group of technologies I'm following called cellular agriculture. And what they do is old and new at the same time, which I love. What they do is they take protein from cows. And more importantly, they take bovine DNA that's 3D printed and they put it into yeast and bacteria. And you might say, wow, that sounds pretty Star Trek, Lenore. It's actually really old technology. It's one of the first genetic technologies. And if you take insulin, it's usually made in this way. And the other big example people are surprised by is rennet. There actually isn't enough calf stomach and sheep stomach on Earth to make enough rennet for all that cheese we're buying in Safeway. And so the product is made with genetically altered bacteria and yeast, and it's called vegetable rennet. And I'm always fascinated that 70 to 80% of cheese is made with a genetically produced product that most of us don't know about. And if you're wondering why on earth isn't that labeled, well, it's because the product itself isn't a GMO. The precursor is. So a group of scientists said, well, if I can do that, if I can make rennet, why can't I make dairy proteins like caseins and lactose? And what we're seeing is a number of products being made in this way. And you might have heard about the burger in the vat. That's a very hard problem, building a burger in a vat. Milk's easy because it's a liquid. And so there is a company called Perfect Day that has perfected this. And they can now produce milk protein in bulk and feed it into the market. And you might say, well, Lenore, when am I going to see this in my lifetime? Well, weirdly enough, sooner than you think, in that they have spun off a subsidiary company that is rolling ice cream out across California. And so pretty soon, anywhere in California, you'll be able to get ice cream that did not come from a cow, but is biologically equivalent. And that is pretty wild. And I have tried the product. I have tried yogurt made in the alpha stage because I'm a little crazy that way. Signed some waivers, tried it. You can't tell it from the dairy substitute. I mean, it's not like Parmigiano Reggiano cheese, but you're just average yogurt you get at the breakfast bar. This tasted exactly like that. And I was like, wow, this is a killer technology and it's going to cause issues. And because I'm a geographer, my first thought is, what does this mean for us and our land base? Well, clearly this will help with lowering the land footprint. And we know that most of the milk substitutes, like the oat milk, etc., use about 5% of the land of a dairy cow. So it's a really big, greenhouse gas reduction. We think, and we're starting to get numbers that suggest cellular eggs about the same. You get about a 5% impact compared to dairy. And my questions, though, because it's sort of what I tend to look at, is, though, okay, so this is probably going to happen. It's probably going to come to Canada. What does that mean for the Agricultural Land Commission and supply management? And what does it mean for the valley? Because the bulk of our ALR is used to do grazing and grow fodder. What does it start meaning if a dairy looks like a brewery? Well, that's an interesting question, and we've been doing some study on that. And we do think this is going to be a new competitor to dairy, much as oat milk is. And dairy farms are going to have to look at this sector and say, well, how do we respond to this? How do we make sure our product is high enough quality, which in the Valley I truly believe it is, that it holds its market share against these tech. Now, one of the reasons I like these technologies is if I look at remote communities where they have trouble getting fresh dairy, they can literally have a cow in a box, except it's yeast instead of a cow. Places like Newfoundland, where the small towns routinely run out of milk, we could actually tackle that problem. We could start producing dairy in a lot of places. We don't produce it now. And that could be a benefit. But one of the things that worries me a little bit is we aren't doing a lot of policy work. There's the science, there's the bench science, but one of my sort of jobs is to make people aware of these technologies, including government. And I actually this last fall did a little demonstration with Genome BC at the legislature. And all the MLAs came and we chatted about cellular dairy, and I think a few of them were a little frightened and a few of them were a little excited, and we all learned a little bit. And what I'm trying to do with sort of introducing this interesting new technology is say, well, I think we're going to see continued change in this sector. And it could change land use locally. It could raise questions for the Agricultural Land Commission about what is a dairy. And it could also create some issues for supply management, because what does it mean when you don't actually have cows, but you have milk? Our team is expanding this study now, looking across the country. And one day we might be stopping by a local cheesemaker who has microbial terroir, who farms yeast instead of cows. And in any event, the future of agriculture is likely to be surprising, and we have to be sure we're ready for that future. Now, I hopefully have left lots of time for questions. I think I have, because I wanted to, because it tends to be a question-invoking topic. So I think that's enough of me being a talking head, and I will turn it over to all of you guys, or the moderator. I can't remember quite how this works.
No worries. Thank you. I'll be another talking head with you, Lenore. So everybody, the chat channel is now open. If you would like to send a question in the chat, we will start going through some of them, and I'll start reading some of them to Lenore. So I encourage you to send those along now. Lenore, I have a couple initial questions for you. You talked a little bit about your childhood, but what really brought you to study and research this area? Was it the milking experience at age 6?
No, I actually have a kind of odd childhood. Like I said, my family were Salmi Finns, and we were fishing Salmi, not reindeer Salmi. There are two types. And I always thought the reindeer Salmi were a little cooler because they had reindeer. But I actually grew up in a fishing family, and my family had a halibut boat. So I was born into the industry, and eventually went and did a physics degree, and then worked in California and Silicon Valley for a while. And then when I went into graduate work, I kind of put it all together, and I kept saying to people, I'd like to study food, and they kept laughing at me and saying, you can't study food, that's not a serious academic subject. Well, it turned out the world decided it was a serious academic subject, and I've done pretty well by being in things slightly before they become popular, and this was no difference. But I would say that early experience in a food industry definitely lasted my whole life. And in grad school, I worked in bars, I worked in restaurants. I just never, no matter how far I ran, I kept ending up in food. It's like that movie says, I keep trying to get out and they keep pulling me back in.
Oh man, wow, I didn't know that about you actually. That's really interesting. So you mentioned early on in your talk that there's on average a 20% increase in the price for farmland. Being in the Fraser Valley, we have a little bit of a limited supply with the river and mountains. How do you think that will affect the farmers in the local area and the future of what Abbotsford looks like?
Well, it's the great tragedy of BC, is there's not very much of it. And of course, also we've had, 100 years of really disastrous policies in some ways that have made land very expensive. I often say the ALR is at a crossroads where it can go two ways. It can be a fancy green belt, like the London green belt, with very little farming, and a lot of people who live very nice lives living in kind of palatial surroundings on nice land that's worth a lot. Or we can continue to have a vibrant industry. And one of the models I like is the Netherlands model. They do something called the Green Heart, where the best farmland is protected and is used for field crops, and its value is held down because that protection is really hard. And some of the more moderate land is used for intensive, and we're very intense, I would say. I mean, per acre, Abbotsford has one of the highest returns anywhere in the country. $15,000, $20,000 per acre on average. The Netherlands does 40. And 40,000. They're still beating us, which is incredible given they have underwater soils, it rains all the time, it's dark, and it's very small. They've become an agricultural powerhouse by using technology to boost output. So I really see our ideal future. We have high-tech, high-intensity agriculture alongside of protecting that really beautiful land. And so I really hope we go that way and not the London Greenbelt way. The London Greenbelt is beautiful. It is not a food protection belt.
Yeah, I definitely don't want to lose my blueberries, so that's pretty important.
No worries on that yet, that's for sure.
Okay, I've got another question here for you. You mentioned geothermal energy that helps agriculture production around the world. I was wondering if you could expand a bit on this. It seems to me that this area has a lot of, this area of the world in BC has a lot of geothermal sources, but little is used. Could it be a sustainable energy option for the future of the Fraser Valley or BC? And how could we use it here for agriculture? How can we harness it?
Yes, and we've had such good luck with hydro. We haven't tapped our geothermal, but we do know it's there. I mean, we have hot springs, we have volcanoes. So it definitely could be, and it's one of the tricks to good greenhouse development is to capture waste heat to fuel them, and that's where Iceland's really excelled. But I mean, you can get that waste heat from anything. I mean, if you have industrial processes that are creating waste heat, you want to capture it. And it's one of the best suggestions I heard when I was on the roadshow with the government was in the far north, where they're doing a lot of natural gas. They pointed out they could use that to grow crops, and that is really good. Now, I will say the lower mainland's particularly good for advanced ag because our temperature gradient isn't too severe. And surprisingly, Iceland is the same. It doesn't actually get that cold. So these technologies work best when you have kind of a cool environment.
Okay, perfect. I know that a lot of Canada doesn't think that we have a very cold environment, but so I've got a question here from the audience. What are the nutritional comparisons between non-dairy milk and dairy milk? Yeah,
well, it really depends what you're using. And I mean, one of the nice things about cellular dairy is you can actually make it identical, but of course you don't really want to make it identical because you probably want to make it better. And just like we sometimes fortify milk, you can basically engineer it to be whatever you want to be. Now, some of the dairy substitutes, and I will say with the proviso, I don't do nutrition. I mean, of course, I know somewhat about it because you sort of pick it up with food. It's some of them I don't love. I don't love almond milk. Partly it's terrible for the environment in a lot of ways, but it's also a little nutritionally thin compared to some of the other ones. The oat milk's actually quite good. But what I love about the dairy is you can make it identical if you really want to. And you can even take out the lactose, which is nice, and it comes out about the same.
Perfect. You mentioned that biosimilar milk can be produced without animals. What other areas of farming do you expect could be supplanted by technology?
Oh, pretty well everything. That's the real truth. We are on the verge of a revolution in biological technology. And that can be everything from tweaking our crops to do what we want them to in terms of producing their own fertilizer, to being more productive. But I mean, we've been doing that for thousands of years. We've been engineering our crops. We've just gotten faster at it. I would say though, the one we hear the most hype about is the lab-grown hamburger. That one's a ways off. I think we got 10 or 15 years on that one because technologically it's quite a difficult problem to grow meat. But a lot of people are putting a lot of money into that technology, including really big companies. And so I think we will see it cracked in the next 10 years. And you'll probably go into, say, Whole Foods, and there'll be lab-grown beef and the like, and lab-grown chicken. Now, they're pushing very hard in Asia to get these technologies down because they can't quite meet their pork requirements, their seafood requirements, and they see this as a good solution. Singapore is actually a real leader in this field because they want to be food secure. They want to be able to produce most of their food within the city-state. And think about that, they have no farmland. That means doing everything inside, indoors, with technology, or floating on the ocean. And that is really different. And one example I would throw out to show how far we can go with this, there's a greenhouse in Iceland now that's producing barley on volcanic ash. You might be like, well, they can grow barley outside. What are they doing? The barley is bioengineered to produce human growth hormones that are used for medical precursors. And this is actually way more efficient and safe than the way they usually make these hormones, which is they extract them, they do all sorts of complex things. They're growing medicine. And these technologies are moving so fast, we barely can keep up with them.
Perfect. I have another question here for you. Do you think that the technology in this area of dairy could advance to the point where it can be done at the individual level instead of just at the industrial level like you're talking about?
Yes, I actually do. And I actually hope it happens that way. Because one of my favorite food stories from BC is basically we were world leaders in microbrewing. In that some of you will remember a time where if you went to buy a beer, it was Molson's and Coors and a few others. Then all of a sudden there was all this beer. Everyone's making beer. People make beer in their closet and then they create a little East Van company that makes beer. It's amazing. And that was policy driven. There are two outcomes for cellular agriculture. One big company making all the cheese, or thousands of little companies with bioengineers in their garage, hopefully very clean garage, making artisan products. And what I really like about that, it still has a bit of that feel. I do go to the annual conferences when they exist in San Francisco and other hubs. And it's a lot of sort of artisan maker type people who want to make one thing work. And some of them are really thinking outside a box. They want to make cheeses from different animals. And one of the weirdest experiences I had is a company trying to make gelatin using these technologies, because animal gelatin has real problems in medical applications because of allergies and imperfections. So they wanted to grow it in the lab. The DNA strand they were using to grow it off of was Macedon. And I got to eat a Macedon gummy bear. And I was sitting there eating a Macedon gummy bear thinking, this is a really weird world. And I don't even quite know how to get my head around this. That's the kind of innovation I really love seeing. I would hate to see it be one really big company.
Perfect. So this is a really great question. What kind of waste is associated with the production of cellular dairy products?
Very little, which is nice. But one of the things I worry about is the input, because what you put into the front end of this is basically a source of carbon, and what they tend to use is sugar. So you feed sugar in, you get stuff out. The problem I have with that is that the cheapest sugar is cane sugar, which we get by tearing down global rainforests and growing cane sugar, and it's a terrible industry in a lot of ways. However, Canada has a very nice beet sugar industry. It's a little more expensive, but it avoids all that problem, and to be honest, they could really use the help. We can also extract sugars from waste food, and I would love to see that. Imagine all your food scraps get sent all fermented down and then fed into this process, and dairy products come out the other end. That's the kind of closed system we need to develop if we're going to actually survive sustainably. So I think that's an important one. And you can get very tightly closed systems if you're clever. And one of the things they're interested in these technologies for is applications like Antarctic bases, Arctic bases, and eventually space travel. They're thinking it might be a really good way to get around the problem of keeping a varied diet on a space station. You need that really closed system.
Perfect. This question kind of brings it back to a local sort of context. What's in the things that you're talking about, what positives do you see for the Fraser Valley with all of this food engineering?
Well, one of the things I think we're really good at making cheeses and ice creams and all these other products, and that expertise transfers. And so I think there's a number of things. I should back up a bit. First of all, is that cultural expertise at making food products. Second of all, we have a ton of energy that is cheap and renewable thanks to all the hydro. And we also have a lot of really smart, technologically based people, and we're connected directly to Silicon Valley, as sort of part of that corridor of innovation that sometimes we call the Cascadia corridor. We're actually really well placed to lead in this area. We just need to have the policy implementation to sort of push it a little bit. And a little bit of government money never hurts. If they're listening, there is an election on. Hello, candidates. It's amazing what you can kickstart with a little bit of money and a little bit of policy to make it easier. And yeah, then we have all this expertise in food that we can shift over. And we've seen that with plant-based. Is ultimately the best plant-based cheese maker is someone who learned to make animal cheeses.
Okay. So with the global climate change and population growth, what are the implications of food scarcity and food security for BC's place in the world, economically and politically? Will this mean BC's taking over the world?
Well, I think Saskatchewan might take over the world, weirdly enough, but we are well placed. Canada is a food superpower. And that's going to be a very good thing to be. And it's why I think this industry is such a growth industry. And we're not really competing well yet with the real agri-tech superpowers like the Dutch, like Israel, like Singapore and Taiwan. But we're doing pretty well. And I think we really do have a lot of opportunity. And one of the things I do think we need to work on here is to convince young people that this is a really interesting and exciting industry, which of course I believe it is, and probably a lot of people here believe it is. A lot of people, one of the downsides to the kind of romanticizing of farming in terms of the red barns and the 1940s tractors and, grandma and grandpa and the pitchforks, young people don't go into the industry. And I always found this odd because in the fishing industry, we used every piece of technology we could find and get our hands on, and to hopefully stay alive and not drown, which in my family was a big challenge, and to find fish any way we could. No one romanticized fishing in the 1890s the same way we romanticize farming. And most farmers I know are some of the more tech-forward people I know. They're also some of the best business people because they run these crazy businesses with giant amounts of money invested. So I actually think we're really good at this, and it's why we can be world leaders.
I'm sure if there's any Saskatchewan Rough Riders fans out there, then they'll be very happy to hear about this. They probably already feel like they run the world. So could these engineered foods be built as nearly closed systems such as that the only input is sunlight and CO2 and the only output is the desired resultant food? So zero waste systems with minimal inputs.
Very close. I mean, at the end of the day, entropy always wins. But if you're putting sunlight in, very close. And really, it is a task we have to get better at. One of the things that really shocked me on the Food Security Task Force was the level of food waste in this province at the production level. It was a little horrifying. And anything that closes those loops, that helps farmers dispose of excess crop, that stops the wastage along the way, we have to get better at that. And to use a phrase, there's a lot of really low-hanging fruit. And I do feel we can get close to perfect systems in this industry. It's also one of the only industries that can become carbon negative, where you're actually sucking way more carbon in than you're putting into the atmosphere.
Wow, that's absolutely incredible. And there's a couple more questions that we haven't quite gotten to, but we're just coming up on the end of our time here. We've kind of flown through the questions. Lenore, I just want to thank you for coming and spending time with us this evening and sharing about this really interesting area that has such a big influence in where we live. And I encourage those of you who have any more questions, I'm sure you could reach out to Lenore and she'd be happy to take some questions. Also, I'm going to go back to sharing my screen. Here we go. So wrapping up, again, we would just like to thank some of our sponsors and want to pass it over to Tiffany.
Hey, Lenore, or hey, everybody. Thank you so much, Lenore. That was fascinating. That is amazing. I feel like I left that with just so many more questions, and I can't wait to talk to you more about it. Yeah, I just want to do another quick thank you to our sponsors. Again, this would not be possible without them. We're here to spread knowledge from our amazing scientists, from them to you. And we couldn't do it without the University of the Fraser Valley, Abbotsford Tech District, Envision Financial, Connects, UFB Alumni, TEDx Abbotsford, Abbotsford Community Foundation, City of Abbotsford, and the Vancouver Foundation. Thank you so much for supporting us in everything that you do. And just another little note, we have some more upcoming talks. There's 2 left in our series. One in November is Dr. John Thomas, and he will be talking about innovative ecosystems. As well as December, we will have Dr. Keith Carlson, and he'll be talking about Indigenous history. So make sure you tune back in for that. It'll be a great time.